Okay, let's look at the homework 3.7 number 4, finding inflection points. All right, so we need to find second derivative. So we take first derivative first. So y prime is equal to, right, so 5/3 in front, and then x, subtract 1 from the power, so you have a 2/3 power, right? Minus 2/3 and 5 times 5, so it's going to be 10/3, right? X to the, subtract 1 from the power, negative 1/3 power, right? Another derivative, y double prime is equal to, right? So 2/3 times 5/3 would be 10/9. Then subtract x 1 from the power, so it's going to be negative 1/3 power, right? Then multiply by negative 1/3, so it's going to be positive 10/9. Then you have x and subtract 1 from the power, negative 4/3. Right? So from here we actually need to pull out, let's see, we're going to write it as, alright, so 10/9 is just a common factor, so pull that out. Then you have x to the negative 1/3, so since it's a negative power, it's going to be 1 over x to the 1/3 power, right? Plus, you have 1 over x to the 4/3 power, right? Right, by taking a common denominator, we can get 10 over 9. Alright, so the common denominator will be x to the 4/3 power, right? So in order to get x to the 4/3 from x to the 1/3, you have to multiply the denominator by x, so we multiply the numerator by x as well. So you probably multiply by x, and you have plus 1. Right? So you can see that you will have a second derivative. So y double prime is 10 times quantity x plus 1 over 9 times x to the 4/3 power. Alright, so in order to find an inflection point, we have to find x value which makes the second derivative equal to 0. So set that equal to 0. Alright, so you can see that which gives you, right? So numerator equal to 0, so x equals negative 1. Alright, so let's do the number line. Look at the sign of the second derivative, right? So here's the number line, right? So we're gonna mark negative 1, so x equals negative 1, right? And we're gonna mark actually 0 as well because second derivative is undefined when x equals 0 because denominator is 0. So I put a 0 here. Alright, so let's look at the sign of the second derivative. So y double prime, so we try anything smaller than negative 1. So I will plug in negative 2. Right? So we just want to know the sign. You can see that negative 2 plus 1 is negative. Because of the fourth power here, the bottom is always positive, so negative over positive is negative. Right? So you have a negative second derivative here. Right, how about between negative 1 and the 0? So we can try negative 1/2. All right. So if you plug in negative 1/2, the top is positive and the bottom is always positive, so it's positive, right? Right. And after 0, so you can plug in a positive value, positive, everyone's positive. So we can pretend that we tried, let's say +1 or something like that, so positive. Right, so there's no concavity change here, and also function is not defined. Actually, second derivative is not defined here. So there's so here there's no concavity change, so no inflection point there, right? But you can see that at the x equals -1, you can see that there's an inflection point because there's a concavity change there, right? So inflection point would be at the x equals -1, so we have to find a corresponding y value. So it's a y of -1 would be, right? So it's -1 to the 5th power is -1 to the cube root. It's still going to be -1. Right, so -1 to the squared is going to be +1. Cube root is going to be +1, so it's going to be just -5. So it's -6. Right, so therefore, inflection point is we could find one of them. It's -1, comma -6. Okay, that's it. I hope that this was clear.